Good morning, everyone. Can you hear me?
Good morning.
Okay, great. Yeah, I guess you can hear me. Hello,
Very clear.
everyone. Welcome to our first session on science communication training. My name is Duduzile Kupeka, and I coordinate the BRICS Astronomy project. I also co-chair the Outreach and Education Committee for the African Astronomical Society. So this is the first session of many. We will have a series of sessions in line with science communication, public engagement, science engagement in general. And the main focus is really around the BRICS countries and the African countries. And if we are bold enough to say we are really trying to cover the global south. And the reasons are, I mean, we've seen, I think when you compare even with literature, there's a lot of engagement and such trainings happening in the global north already and not so much in the global south. And we have a lot of practitioners and even scholars in the space, but we just haven't really connected well enough. So this is in hopes of building a bigger community of practitioners and academics so we can help each other in advancing this field of science engagement in the global south, but also because we want to improve the work that we do. You know, if we are going to engage the public, we want to make sure we're doing it well and we are guided in that sense. This session is also really for a lot of researchers who don't even know where to begin when it comes to science engagement. And we are hoping through these regular engagement, they will also gain the confidence to grow. So we are really starting this now, but it's going to be ongoing for years and years, where we will also be partnering with various academic institutions, and we'll try and, have certificates for people who participate and improve the content that we provide. So at the end of the program, we will definitely be sending forms for people to, review and give us feedback on the program so that we can be able to continuously improve it. So without taking up much time, I will introduce the speakers, and then the first one will start. We'll have a short question and answer session after he finishes, and then we'll have the second speaker, and again another short Q&A, and then the last 30 minutes of the session will be discussion and more questions and answers with everyone else. So the first speaker for today, who will be focusing on the first theme of the session, is Dr. APJ. He will say, he will introduce himself also properly, but he's Dr. APJ, and he will be giving us an overview of science engagement, its importance and impact. So Dr. APJ is quite an experienced science communicator and scientist who has years and years of experience. He's currently the president of STEAM Academy and the chairperson of the National Center for Science Communicators. He's also an elected member in the PCST Global Network Scientific Committee. He serves as a member of the academic councils of several prestigious colleges, and he is the president of the Indian Development Foundation. Thank you so much, Dr. APJ. You may start now with the first theme of science communication, its importance and impact, science engagement. Thank you so much. You can start. I'll mute myself and yeah.
Thank you, Dudusile, for that introduction, personal, and more that insight into what we plan to do in future. The Global South. The Global South, if you weigh in grudging scales, science communication needs to be kick-started there in a very different fashion. That's my basic assumption. Now, about me, I'm basically a nuclear scientist, having worked there for 40 years in scientific research and 60 years in science communication. So that's my general background. And can you help me with my slides? Dudusile, can you help me with my slides?
Are you trying to upload or do you need me to upload for you?
Yeah, if you could do it, fine. I am trying. I am not able to succeed. Yes. So it will be great if it's done at your end, if you have an IT.
Okay, I can upload on my end.
Oh, great. Thank you. Yes. I'm on the first one. Yes. So that's my general background. 40 years in scientific research and 60 years in science communication, and I'm an octogenarian of that order. Yes. Can I move to the next slide? Yeah. I'm a global science citizen, but my origin is India. And in India, I belong to a small state down south called Kerala. It's often called the God's own country. It is also called a lunatic asylum, where one of the finest experiments in science communication is going on and was conducted 50 years ago. We have about 35 million people over there. Ours is a feminine state. We have 1,084 women for every 1,000 men. We occupy about 40,000 square kilometers, but we have 2 scientific workers per 100 of our population. For every 10 square kilometer of our area, we have 15 science activists. So we have made this state livable and diable. That's the beauty about it. We have about 60,000, 65,000 science workers today. 25,000 of them are women. Surprisingly, slightly different from the rest of my country, although we are very rich in science communication, we have a higher human development index, 0.78. And we have also a higher life expectancy. I'm not correlating all this with science communication, but there is a strong relation, if not a correlation. A life expectancy for males at 75 and for females at 81. What's more, like Guarapari of Brazil, we have some of the largest radioactive areas in my state. 4 milligray per year is the exposure in that area. So here in the crucible of our society, we conducted an experiment, a brave new experiment in science communication with the slogan, Science for Social Revolution. That's now described in literature as the Kerala model of science communication. It was world's first people's science movement. So we can see the genetic evolution of this factor of science impacting people's lives in a very, very significant manner. Next slide. It all started with 1 doctor, 2 teachers, 4 scientists, and 4 engineers. So that's the composition. They were the bandwagon at the beginning. So you will find it was a teacherly reaction. The chain reaction was started with the teachers. A science teacher started. Then we were influenced by the Russian Revolution. One of our pioneers, an engineer, a nuclear engineer, had been to Soviet Union. And he was impressed by the science communication of the Sputnik age. When the Russians sent the rockets into space and the entire world was jubilant over conquest of space, he was witness to and a participant to that program in Moscow. What is more, he also found out that Russian language was used for science communication in Britain. So these 2 aspects, that science can change the history and that science should be taught in the language of the people. These were 2 convictions with which he returned to India. He came back to the atomic energy establishment. We were all colleagues, and he asked, let 100 flowers bloom. And 100 scientists revolved around him with him as the nucleus. That's we were the electrons around him. And we decided that our language, the home language, which is called Malayalam, M-A-L-A-Y-A-L-A-M, it's a palindrome. You can write it forward and backward, it will mean the same thing, should be enriched by creating, fabricating, engineering, vocabulary, and semantic vectors to handle the advanced cutting-edge science and technologies. That was a brave new experiment he conducted, and we have largely succeeded in that. So a short narration I have made about this. This is the largest people science movement today. Next, please. So here we will try to see a formal introduction to science communication begins with the word science. What is science? If you ask any scientist, you will get one definition. If you ask another scientist, you will get yet another definition. Then you have the hard sciences, the physics definition, the chemistry division, the definition, the physical chemistry definition, the chemical physics definition. You will get a multifold of definitions as far as what is science. And ultimately, if you want to give from the scientific communicators' point of view, science, as Bertrand Russell aptly put it, is science helps us to know and do things. Knowing and doing things, that is what science is. Of course, there are peculiarities and singularities, and therefore science is what scientists do. What I do in gas chromatography may be entirely different from what's the gas chromatographic approach of my Japanese colleague. So science exactly depends on the very specific conditions under which a scientist performs. But the problem in science today is we all know that K, the knowledge, and D, doing, are very important. But on the entire wide, broad spectrum of scientists, you will find people, average and below average scientists with small k and small d, a little knowledge and little doing dangerous things. If you know little and if you do a little, then that's pretty bad. Then we have the librarian scientists who spend their majority and vast amount of their time, absolutely absorbing every printed word with a huge amount of K capital. And they do very little in the laboratory. Again, a sad state of affairs. Then we have the over-enthusiastic, hyperactive scientists. They know a little, they get an idea, they read a paper, or one or two, and immediately they jump in a conclusion in the scheme of events. The small K and the huge development work they do. The ideal situation is there is a balanced equilibrium between knowledge and doing things. So that's the ideal situation as far as the laboratory culture is concerned. Now, if you also look at the origin of the word science, it was evolved, it has started, in fact, it's coined first in 1834 only. It's not a very old word. And less than 200 years old. It was William Whewell who created the word science, meaning knowledge. So science came to be equated with knowledge. Then knowledge became equated with wealth. So that is the knowledge component. Or if you are very familiar with T.S. Eliot, in his Wasteland, you will remember the word, where is the wisdom we have now lost in knowledge? And where is the knowledge we have lost in information? And where is the information we have lost in data? So we have this hierarchy now of data, information, knowledge, and wisdom. And science communication needs wisdom at a higher level. From data to wisdom, the transitions which we are able to absorb is exceptionally important. Next, please. Yes. So what is science? We may have diversity of opinions, but what is not science? There cannot be much difference of opinion. The non-science or the unscience or the anti-science aspect, the entire contrarian view of science is widely known. Yet, some of us hold very personal views of faith without any evidence. So, evidence-based reasoning, validation of hypotheses, falsification of hypotheses, acceptance of the falsified hypothesis and re-hypothesis, that needs a scientific bent of mind. We also find a large amount of pseudoscience, looking like science, but not actually science. For example, if you are very fond of walking on a green grass in an early morning with the dews on it, it's a very pleasant experience. But if you say that the free radicals on the tip of your feet are interacting with the electrons on the surface of the grass, then you are making a pseudoscientific claim. Speaking the language of science, using the words whether those words mean what they are. Do they represent the reality? Is there a physical correspondence between what you say and what happens over there? So that's the problem with pseudoscience. Then also you can make claims like astrology, where you have untestable factors. So that's another aspect. And then we have fixed, there are people even today, there is a flat earth society. They believe very strongly, romantically, that the earth is flat because they cannot conceptualize, even when the satellite picture is shown to them, the blue dot, they refuse to recognize the facts shown by hardcore boiled evidence. Then we speculate with hypothesis not subjected to either experimentation or observation. All said and done, we are all products of our emotions and feelings. And we do have very personal views, which we do not weigh in the grudging scales of evidence. Apart from that, superstitions, average superstitions, now we have higher superstitions in science, where you are speaking about pseudocentric alarmism, Afrocentrism. So there are many, many views as far as the anti-science is concerned. It's better we know the landscape and we are familiar with that. So we have the rationalist movement, we have the strong atheist movement, and we have a wide spectrum of those categories. So science is all that we have to remember is science is about evidence and not untested or untestable claims. So that's a very rough operating experience or an operating definition for science. Next. Yes. So let's do a thought experiment, the dilemma of science communication. It has been estimated by UNESCO that we have 8.8 million scientists. 8.8 million scientists. Do we have 8.8 science communicators? Is every scientist a science communicator? In which case, we have a good population of 8.8 science communicators. That raises a question, is it easy and comfortable to teach communication science to scientists or science to communicators? You have two ways of reaching this. Either teach communication science to scientists or science to communicators. And the challenge is, scientists are excellent communicators with respect to their hierarchy, to their peers and to their colleagues. They can without any deviation, error-free, they can make communication. And we find the spectrum of communicators, they can excel in their outreach programs, taking public awareness programs, in taking science to the people. But they may be deficient or insufficient in scientific depth. And the solution will be, the golden solution, the golden mean of the solution will be foster psychom, bridging scientific rigor with effective outreach. That's easy to say in the classroom, but doing it is a big problem. The other approach could be, psychom could be part of every scientist's science education. And should we cultivate specialized science psychomers? These are a few thoughts that wander through the landscape of science and science communication. Next one. It is important to remember that apart from the human resource of 8.8 million we have right now, we have a huge monetary capital sunk into the science empire. It was 1,000 billion US dollars in 2000, and 2 years ago, it stands at 3,000 billion US dollars. That's a huge intellectual science capital we have put in the market. And we have the human resources over there. That raises the existential question, are we communicating these facts, the products of this research, to the people for whom the investment was made? It is for the people. So whether there is a dramatic democratization of the output and the products from scientific and technological pursuits, that's another question that looms large over the landscape. Next one. Yes. So we take another word, science. We had a look at it as a semantic vector. So the next one is communication. How do we communicate? Of course, communication is a specialty of the human species. We know that chimpanzees and primates also do communicate in their own way, but at the moment we are concerned with human communication. You'll find one of the classical definitions given by McFarland. See the definition he has given. Process of meaningful interactions by which meanings are perceived and understandings are reached among humans. Quite tautological. Meaningful interactions in which meanings are perceived. Meaning is what we find and significance is what we attribute, and then we become totally unscientific. So communication is something which we practice very often. It is the essence of life. Yet, when it comes to a scientific definition of the process, then we have difficulties in that. We all do it. In fact, the more ingrained a phenomenon is to our system, the more difficult it is to give a concrete, repeatable definition for that. Next one. Yesterday, I was reading this book, Science Communication, The Basics. A fantastic book, a fascinating, scintillating book, by which gives the French-Gucci paradigm on science communication. An intellectually stimulating text, very good for the classes. They have brought a new paradigm, social conversation around science. Note the 4 words, social conversation around science. Of course, Brian Trench also discusses the singularity and plurality of conversation, saying conversation and conversations are semantically different. These are the semantic vectors he has used. It's a fascinating book that brings a new dimension to the discussion of contemporary science communication at the academic level, at the strategic level, at the tactical level, and at the very operational level too. Can I move to that? I would like to move to the Global South story. Yes. The Global South, what has been here? In that textbook by Brian and Bucci, you will find Liz Meitner holding a conversation with some girls and girl students, her research students. So that is a relaxed, freewheeling conversation when the concepts are made clear, with no formality involved, with in the free flow of electrons. So that's like an electric current, the concepts move around with the lightning speed of light. So that's called a conversation. And that's the conversation which Brian and Kuki were speaking in their book. To the Global South, the country which I belong, we have the Gurukula system. In the Gurukula system, the transmission of knowledge was by a conversation. But conversations have to be informed conversations. They have to be informated conversations. Who begins the conversation? You can't have start a conversation with nothingness. You need a point of information. And it always flows like from potential energy to kinetic energy. There is a source for it. So you will find a teacher or an experienced person or a person who has abstracted his experience into a translatable form. That's the Indian form of Gurukula system of information exchange. On the Greek side, we have the Platonic dialogues, the method of didactic methodology, which has been used in argumentative fashion to arrive at evidences. We have also been trying in the Kerala People Science movement these workshops where freewheeling conversation is done. We were trying to evolve a workshop on creative science storytelling for teachers and students. How to teach the scientific method, common to all the physical, life, engineering, and geospace sciences across the 8 to 12 spectrum. How can we engage students by creative science storytelling? So we used to have very freewheeling conversations in that. So conversations, and particularly informed conversations, with a view to informating the conversationalists, those in communion with that conversation. That is one of the techniques we have tried, particularly for the creative component of science communication. Next one. So in a textbook fashion, if you look at the goals of science communication, every corporate sector, every research institution, every research establishment, the space establishment, or the atomic establishment, you will find we have to raise awareness of the people around us. A community of ignorance and a center of excellence that is incompatible. Then we need to influence attitudes. Can we do persuasive arguments with respect to the people, particularly on environmental issues, say siting of a nuclear reactor or fixation of a fertile launch center, yes, or location of chemical factories, yes. Then when government takes decisions at the higher level, the policy is being lobbied. There are lobbyists and influencers and confluencers who are able to to design the policy of the government. That is very important. Then you have the non-profit organization, the NGOs, who are finding out what is the impact of the science and technology on the body social, on the body society, and what are the impacts which have to be identified with respect and evaluated so that they could be controlled. So that is the scientific social responsibility of the scientists, but this is now largely done, scientific social responsibility is now largely done by non-profit organizations, particularly by the young senior scientists. People after their retirement, they resort to this very, very crucial social responsibility, which we call scientific social responsibility. Now, if we do not have adequate number of trained scientists, then our economic progress, our HDI, our welfare measures, 17 SDGs, all of them will come to a grinding halt. But a population with no scientific knowledge to make democratic decisions, that's a great liability. In fact, it will be a historic challenge if democracy is not matched by adequate information. An ignorant public that's missing out on deeper understanding of the STEM world, science, technology, engineering, maths world, will be a societal liability. Next one. So we look at what is quality of science communication. Whatever is being pushed out or radiated in the form of science, science news, science journalism, science communication, science conversation, it has to pass a quality assurance. The quality of mercy is strained, said Shakespeare in one of his plays, but the quality of science communication is also strained. Is it scientific? Is it factual? Is it authentic? Is there scientific rigor? Can this source be trusted? So sourcing management in science communication, which peer-reviewed reference journal you are referring to? Are there contrarian views? That has to be checked. It's not enough if you have a big bag of truth and scientifically validated facts with you as a communicator. You should have evolved, you have to evolve your own presentation style to make it acceptable to the public. So that is the second aspect, presentation style. Then comes the connection. Do you have listeners? Do you have readers for you? So that is the most important one to do. Now, I just want to mention an aspect of science communication happening in some of the global south in the Indian languages, one of the particular language which I mentioned a short while ago. When we prepare a science communication piece, we have to prepare two to send it to the editor, who will evaluate it in terms of its acceptability and readability by the public. Then the topic will come to you and you have to give the peer-reviewed reference to that. Then we prepare a 500-word write-up in the language in which it's going to appear, and give it to the editor. And then we would like this to be prepared, that will be seen at the editorial levels for acceptability. In fact, the words are, today every word has connotations, undertones, and overtones. So that's all being moderated. Then comes the new trend. If the science piece is coming tomorrow, the author has to give a 2-minute video presentation on the content what he's going to see. That will appear first. So the process of making a science article in some of the regional languages in global south is quite demanding. So that's one experience I want to share with you. Can I move to the next? Next one. May I have the next slide? These are, I am at 14:31, 30 minutes. So I need another 10 minutes. Can I quickly move over the next slide? Still next. There are barriers to science communication. Yes. Let me just give you quickly 5 case studies of how do we do science communication. First one, please. Next. Yeah. Here is the Indian Nobel laureate, Sir C.V. Raman, for his Raman effect, well known for that. So when we take this topic, eccentric science communication, that is, we take an egg. When I take an egg, I do not know whether it is an egg which will be a male chick or a female chick will come. And if it goes through an incubator, and if all the eggs are incubated and the chicks come out, 50% of them will be male. And that is not fit for the poultry industry. Therefore, they have to be culled and liquidated from the sea. To avoid this huge loss to the poultry industry, Raman effect is being used. You take the Raman spectra of an egg, and you will come to know whether it's a male chick or a female chick, and then you can avoid the culling aspect. With this eccentric psychon Raman effect, we are able to tell the novel work done by Raman. What is Raman effect is? Raman effect's importance in across the industries, and in one of the most economic advantages of applying this technology in the poultry industry. Next one. Now, this is the kitchen story of Psychon. Over there, you find one of the kitchens we have developed as our people science movement. All our mothers and females at the home were virtually crying because we were burning firewood, and firewood produces smoke, and that is carcinogenic smoke, and there is no ventilation. So we modified the native furnaces and made this and here. So that's the story of a kitchen. But more important than that is the story of the modern kitchen. You have the Teflon coated pans you use, and you have the steel ladle for that. And when you scratch your Teflon coated pan with the steel, you will come to know that polytetrafluoroethylene has come out, which is one of the carcinogenic compounds, and how a carcinogenic compound which was there in olden times in my grandmother's time, and the new toxicological components which is coming to our air by improper use of materials. So that's the SciComm story which can be woven on a kitchen-centric platform. Next one, please. Yes, now we come to food-centric SciComm irradiation, or which we call the nuclear spicy pancake. The spicy pancake in India is called dosa, D-O-S-A, and we have what is known as spicy dosa, which is called masala dosa. So we have now used atomic radiation to process the rice, to process the spices, the chili, and other spices which we add, so that they're absolutely E. coli free. And then we use radiation for radiation sterilization of potato and onions, by which we can stop their sprouting for 6 months. So a totally radiation processed system has been used for making one of the finest delicacies of our kitchen. And the story of that is a food-centric SciComm irradiation. Is an exciting way to take this. These were the tried routes by many of the science communicators of my time. Yes, please. I will stop here. Yes, we can. Now, I would also suggest that you should have SciComm stories about climate-centric bananas. Bananas will extinct very soon. Next one, please. The last one is on a nuclear waste. Today, we are all craving for energy, and there is a new renaissance for nuclear energy. When nuclear energy is going up in a big global scale, there will be radioactive waste, and radioactive waste has to be managed. But if you go to Gabon and look at the Oklo phenomenon over there, there's a natural waste management process. This type of news should be brought out when energy discussions happen. Next one, please. Probably the last one, yes. You can make a science story by what came this morning in the newspapers. Mosquitoes can be, if a mosquito bites you, and if you take that tablet in nitisinone, the mosquito will die in 18 hours. We have also radiation sterilization methods with attracting the male mosquitoes with a pheromone, heptacosate, treat with radiation sterilization. So these are the compound stories, science communication, which we can take to the students and to the teachers to engage them in interesting fashion. Thank you.
Thank you so much, APJ. Thank you.
Thank you.
All right. Do we have any questions before we move to the next speaker? We will also have time for discussions later after the second speaker. So if you have a question, please raise your hand. I think we haven't allowed people to unmute themselves, so please raise your hand so we can allow you to speak. Yes, Sibsankar. I hope I said it okay. Please correct me if I was wrong. You can.
Yeah. Sir, thanks for the wonderful presentation. I just have a short question. Like often as science communicators, I believe you and many others have faced initially that how much information or how much to share with the public or those who are, let's say, amateurs or non-technical to be right. So because there is a lot of information to share, to how to understand that how much to share so that they understand it and welcome the facts rather than the other things.
Yeah, that's a very complex question. Even most of the science is done by government and by strategic departments. And therefore, a large amount of information is classified information. We can only deal with information which is available in the public domain. But when it comes to daily use items, the chemical toxicity of the materials in the public domain. So we need to know the materiality with which we encounter in our daily systems, and there should be thorough exposition of all the factors, the market forces, the health aspects, the toxicology perspective, and the doctor's perspective on that. So we need to give information which is weighed in very, very grudging scales and always backed by a group of scientists or a group of experts, subject matter experts, the authenticity of your information. Where do you source your information? Your sources of information authenticity. Is it on peer-reviewed journals or is it based on hearsay? Or is it the commercialism or the editorials which are coming in the newspapers? So you have to be very, very safe. Every science communicator has this additional responsibility of validating its source. And if you are not very sure, absolutely sure of the source, please do not radiate that news. So extreme care has to be exercised in selecting your source, and definitely try to have a dialogue with two experts on the subject so the nuances of the subject will emerge, and then you apply your own creative critical judgment. I think that's a science communicator's job is pretty difficult.
All right, thank you for that question. The next hand was Sanya Panda.
Hello, hi everyone.
Nice. Yeah.
Yes, Doctor, thank you so much for the amazing presentation. I have a question around nuclear waste management. So we, come across a lot of negative connotations around nuclear, industries. And one of the main things I feel is improving strategies to communicate and create trust amongst the public. How do we do that as science communicators is my question.
This is a challenge to science communicators and a contemporary challenge. I would say this is a challenge which is right now at your doorstep. It's knocking at you. We have the nuclear era, the new nuclear renaissance is going on throughout the globe. We have China building several reactors, Rosatom building several reactors, and nuclear reactor, because of the fear of the carbon tax and the net zero, we are anxious that we should not burn our fossil fuel. So as an antidote to the consumption of the huge amounts of fossil fuel, the only reasonable alternative to us for baseload capacity is nuclear power. So reactors will be larger in number, and small modular reactors will come into view. And two questions standing before the nuclear industry is this: accidents and radioactive waste management. Absolutely safe engineering practices have been in position. to avoid repetition of the bad, ugly incidents of Fukushima, Chernobyl. They will not be repeated because we have learned the lessons, the hard lessons have been learned. The second question, which is being debated by the public, is about radioactive waste. What will you do with the radioactive waste for thousands of years? Not thousands of years, millions of years. Human life is, say, 100 years. Reactor life is maybe 100 years. But you are creating a radioactive waste as a liability to posterity. So that was a philosophical question appearing before the scientists. What is required? The solution is a proper engineering solution. If you can take the high active, long-lived radioactive isotopes, concentrate them and contain them in an appropriate matrix, like borosilicate glass. Several glass formations have been tried. Glass technology and glass material technology has improved to a great extent. Borosilicate glass has been found exceptionally suitable. And you have engineered facilities where it can be stored. What is more, in Gabon, the Oklo phenomenon, 2 million years ago, nature operated a natural reactor where water interacted with the high radioactive, with the uranium-235 component of uranium, 235-238 ratio, and the reactors operated. When those reactors operated, there were waste, there were fission products. Those fission products remain totally contained and isolated within a narrow sphere. That's a geological proof that we can manage radioactive waste. That is why I suggested in this conference that Gabon Oklo should be brought to the attention of the global community. And this is the duty of the science. This is a challenging duty of the science communicators to look at radioactive waste from the difficulty portion, but from the solutionist perspective. So I'm glad this question was raised, and this should be sensitized to the scientific community that they should write about radioactive waste and how it can be managed by appropriate safety engineering practices. Thank you for this question.
Okay, thank you. Thank you so much. I'll take the last two questions. I saw there are two hands. There's Ferguson Awuni and there's Kamishwa. So you can go first, Ferguson, and then after the question is answered, Kamishwa can come, and then we'll close this for the next speaker. Ferguson, or should I just read the question you wrote?
Is it in the chat box? Could you read it for me? I am not able to.
Yeah, so my question revolves around systemic obstacles. Like mostly there are certain communities that are very sensitive with regards to their religious beliefs and superstitions. So outreach to by the Department of Physics, KNUST, to educate them about the extraterrestrial environment beyond the Earth. And we faced their belief system was hinged around the entire universe being just the Earth. And so we trying to go beyond the Earth nearly caused a bit of some big problem there, and we almost got attacked. So how do you deal with those systemic belief systems that directly clashes with scientific discoveries that you need to actually really communicate out there?
Thank you for this most difficult question, which started from Galileo. When scientifically established facts conflict directly and confronts faith systems, there can be no compromise. But if science is to survive in its nascent period, it had to make compromises. Like Galileo said, a persimoi, it moves, although he had gone through the whole process. Now, if you have the material universe, 13.5 billion years ago, the singularity, the Big Bang, the Stanley Miller experiment, the origin of life, the evolution, Darwinian evolution, you have a system of faith which is quite coherent. But that is not the system which has been taught to us in the question of faiths. So the question is, most scientists carry both the baggages. 8 hours on the scientific side, 16 hours slipping back. Boot and suit in 8 hours, kimono 16 hours. So this duality, I'm not referring to the Schrodinger duality or the particle wave duality, but the faith, non-faith system, it is part of an intellectual culture. But there are a few scientists who have been able to get rid of the faith system and they live totally on the scientific system. But the society as such has not become. So we have atheists, rationalists, non-believers, all sorts of things. There are groups of people who use methods of science to dispel superstitions. For example, the magic, creation of ashes from somewhere. So those types are being countered at the level, at the operational level. But at a theoretical level, at a sociological level, this dichotomy does exist and individuals have to find their own solutions. But ultimately, we believe the investment in science, the scientific temper, scientific rationality, for example, my country has built into the constitution scientific temper as one of the virtues for a citizen. But building into the constitution, practically delivering it and making it happen, that's a different thing. So until the world mindset goes into a more secular, a more scientific oriented one, this dichotomy will persist. But yet, even the most faithful scientists, when they come to the laboratory, they are not inspired by those faiths. They have their scientific faiths in that. So at the moment, the question remains unanswered by me, and probably no textbook has an answer for it. Individual scientists will have their own answers and convictions, and on a large scale, each one stands at differently. The ideal one is very different. This is not an answer. This is only a response to a basic existential question you have asked.
All right. Thank you. Thank you so much for that discussion. And then I noted the last question from Kamishwa, how to convince normal public that science is necessary for them. And I really think the discussion by the next speaker will be addressing a question like this. If not, we will definitely note it and respond to it after Thembela speaks. So please just be a little patient with that. I promise it's going to be answered soon. And then with that, I will then move on to introducing our next speaker. Thank you so much, APJ, for that. You will still stay on for the discussions later on.
Yeah, I'm here.
Yeah. Now I would like to introduce Ms. Thembela Mantungwa. She has a master's degree in public relations and is currently pursuing a PhD in media and communication. She has extensive experience in communication spanning over 10 years. And she works at the South African Astronomical Observatory, where she also chairs the communication committee for the African Astronomical Society. Her research interests are in relational communication and the particular way in which the institutions engage with society. So please, you can go ahead, Thembela.
Thank you, Dudu. I'm going to share my screen. Okay. Everyone can see my screen?
Yes, we can.
Perfect. Good morning. It's very hot in Cape Town, and where I am it's freezing. That's why I'm wearing this jersey. So I think what is key in dealing with media is that when you think about your science, so you think about the ways in which you want to communicate your science with the wider audience, it should not be an afterthought. That's one. Because oftentimes a lot of people realize once they've published that, oh, might as well just write a press release. But you have to think about what it is that you want to communicate and why. Because for every single story that we tell, even today, we are gathered here, there is a reason for us to gather here, as Dudu has contextualized the meeting. So we have to think about why you want to share your story, and also who is it for, because we do not have a blind audience that we want to share our stories with. There is a specific group of people. So once you are published, you want to go to a conference and present your study to your peers or to people who are interested in your study. That is one audience, right? And after that, because your science is also funded by government or funded by whomever, you want to also talk to those people about your science. But the ways in which you share the knowledge is going to be different, because these audiences are different naturally. So you also pick out what it is that is going to appeal to that audience, which is why you have to think about what is it that you want to share, and also the techniques of sharing your story. And so in the way that you're thinking about it, you have to also understand the goal. What is it exactly that you want to achieve with your story sharing? So in this instance, I'm going to use this room. In this instance, in this particular talk, what we have noticed is that a lot of researchers lack media training. So if that is the case, then what is it that you need? So what is the goal? The goal is for you to, I don't want to use the word empower, but the goal is to prepare you. Yes, the goal is to prepare you so that when you are in a situation where you have something interesting to share with media, what is it that you have to share? And in the understanding of media, you also have to understand that media has a broader audience. And within that broader audience, there is a specific message that they're looking for. And I will use a South African example. In South Africa, because research is funded by government, we're looking at, in particular with astronomy, we're looking at all the telescopes that we have in South Africa. So we want to understand, are these telescopes being used as the members of the public? Are these telescopes being used? Who's using them? Why are they using them? And what comes out of them? Are they effective, or are they just, white elephants in there? And then you also frame the messaging up, accordingly. And so when you absolutely think about it, you have to have that in mind. What is the goal? Who is the target audience, and how do I frame the message, or what is the messaging? And it's the same with when you go to a school and you want to talk to learners. The way in which you're going to frame the messaging is going to be different to the ways in which you're going to frame it when you are talking with government, or when you are talking with people who are of age to pay tax. So the way in which the audience is described is all of this. So you're looking at people who are tourists, and we say tourists because, like in South Africa, we have a lot of observatories that have provided access to the general public. We look at students. Universities want to position themselves as being the fore in scientific and in scientific inquiry, and that is a way to attract students who might also be, leaders in their field. The general public are people who are paying tax. Journalists are also people who are talking to a wider audience, depending on each publication or radio or whichever medium of communication that they're going to use. And you also want to attract a lot of people who make decisions. Maybe your work touches on the policy. So if your work also touches on policy, you also want to talk to people who are decision makers. That's why we have things like science forums and all of that, where you have to discuss your science or present your science in spaces that allow for a bigger audience and ears that are likely to make decisions based on your work. And then there are also people who work within scientific institutions who are doing outreach, who are doing science engagement. Those people also want to know what it is that you're doing, so that when they go out there and they are talking to whomever, the public, parents, or learners, they know what you are doing, or what the kind of research that is done in your institution. And then, of course, you know, with research, you have to present at conferences and all of that. And then, you know, if you're lucky, maybe your institution has industry links, and so your work then becomes effective in that way. So we have to think about these things, because there is no blanket audience. There are different people within, you know, within society who are looking for your information, but for different purposes and for different interests and different understandings. And so when you are writing your, whatever it is that you're writing that relates to your science, you have to think about those things. So let's say, for instance, the audience that you want to reach is one that is covered by media. So whether it's print, whether it's radio or whichever. But the ways in which you are writing a press release is completely different to the way that you will be writing your science journal. So your science journal will give, you know, like the overview, introduction that is longer so that you contextualize your study. However, with the press release, it has to be one page, it has to be short, it has to be to the point, and you also have to highlight the interesting points or the salient points about your work. So we don't want a lot of explanations. And I find that sometimes a lot of researchers will have a professional disagreement with the media person or the public relations person within their institution because of these things. They're understanding that, oh, there is longer, there's a bigger story to this. It's not this. But the person within your institution who's a public relations person, their way of thinking is that, what is it that you have done? Why is it that you have done it? What is important about your work? And I think this is where a lot of researchers have an issue with media, because the worry with them is that if I shorten this, or if I make this simpler to understand, then I'm likely to be misquoted, or my work is being simplified when it should not be simplified. And sometimes they fear that their translation of their work into plain language, it might lead to devaluing the work. But then when you arrive at that point where you feel like these are your concerns, you have to remember who is the audience. Why is it that I want to have a press release? And what is then the message that I want to have out there with this audience? Because the research community wants something completely different, and what you want to achieve with the press release is completely different. So constantly have to think about that. Okay, fine, this is a different audience. So therefore, the way in which I position or the way in which I communicate my science is completely different to the normal way of thinking about my research. But what I want to privilege in the way that I communicate is what is important. So when we also think about the press release, now you are at a point where you are writing your press release, you have to remember that there are ways in which we write stories. What did I do? Sorry. The ways in which we write stories. What have I done?
What we can still see your screen. I'm not sure.
Perfect. Because I can't. So the ways in which we are thinking about the story is that you have to think who, what, where, when, how, and why. And the essence of that story hinges on the why. Why is it important? What kind of problem were you trying to solve with your research? And who benefits from it? And why should we care? Because that's another thing that is very important. Why should we care? If you have discovered, I don't know, like a planet orbiting another, why should we as the general public care about that? What is so important? And also, when you think about it, it's like other people who are reading the story, why should they care about, about your discovery. And when was it done, and why is it so important that it has to be in the public domain? And I think also this is a very interesting thing, because a lot of people tend to think that because I do science, because this is of interest within my community in research, a lot of people tend to think that it's probably going to be interesting also to the general public. But when you have not thought about why it would be interesting, then nobody's going to see why it would be, why it is interesting. And maybe other people look at what is it that they were curious about when they started, which then makes it more important now, because I have discovered this. I never thought I would be able to, I never thought it would lead to this, and this is why this is important. And also what then happens, because it's one thing to say, I have discovered this. What will be the research that will happen? What is the significance of what you have discovered? And going forward, what should we expect? And then the other information that follows then is also important, but it's not as important as contextualizing the story from the beginning. And then you get to the point where you have, like you write about the debates that are happening within the work that you are doing, the details, the facts, and all the other information that is important, but not as important as us understanding why the story was so important. And then you follow up with the less important information. So this is key, because without the story flow, then it's very difficult for media to pick up your story or to understand what it is that you're trying to say, and it cannot be long. And I cannot emphasize it more that whenever you are writing a press release, you also have to understand that it is just a statement of facts, and it's just one page, and it shouldn't have pictures in between, because you're not writing a feature article. You are writing a statement of fact about what you have done and why you have done it and why it is important, and you want it out there so that people, when we are reading the story, we can read the flow. You can attach the images if you want to, or you can create a link for the images when you are sharing your story. And so the different mediums in which you can have your story. And the thing is, it doesn't only have to be a press release, because it might be interesting, but maybe not interesting enough for you to have it in the for you to write a press release. But it is information nonetheless that is important. So it could be in print, depending on the platform that you are using. So in South Africa, I think, I'm not sure if Quest also allows for BRICS countries to publish in there, but there is the Quest magazine that is under ASAF. What is ASAF to do? Please add the information on the chat box, what ASAF is. So, and then there is radio. And a lot of people tend to think that for the story to be effective or to be important, it has to be on the commercial radio stations. The community radio stations in many communities or in many villages are used as a medium to share information that is important to those communities, and they have a huge listenership. So if you don't make it to the commercial radio station, you can also try the community radio station, and a lot of these community radio stations will have updates on, I can only think of it in its close, it's like important information that is relevant to the community. And also because a lot of kids are trying to decide and understand which careers they could go to or they could follow, then this is also important, because when you're talking about your science, you can also talk about your career and say, okay, I studied this and this is my research and my research is doing this. There is also now a drive and a bigger wave than radio, maybe, than print. It's podcasts. I like them because there is also the archiving of the information. So you can go back, especially for those people who are worried about being misquoted. So there are a lot of podcasts that you can go to, and you know, you can approach these the host of the podcast and say, I would like to present my talk, or I'd like to talk about my research on your podcast. These are the things, these are the important things. This is what I have done. This is how I have done it. This is why I have done this, and it's relevant because I've done it in this period of time. So this is also very, very important. And there are many podcasts. So for those of you who are funded by the National Research Foundation has the NRF Science Matters podcast. You can approach them and you can say, well, this is my work. I'd like to talk about it. I'm funded by you, and this is the work. And then there is also the Root of Science podcast. And for those of us who are within the continent, this is a continental podcast. You can go to NCHISA and say, I have this is the research I'm doing. I'm based in this country. I'd like to talk about it. And of course, you follow the storytelling program of saying why, when, how, and all of those things. And then there is also the digital platforms. And I think a lot of scientists don't necessarily use the digital platforms much. I'm not sure if it is because of the fear of being misquoted, but last year I attended a conference, and I met one of these important or very famous researchers, and she said most of her collaborations came as a result of her talking about her science on the digital platforms, your Twitter, your Facebook, your LinkedIn, and all of these platforms. And you don't know who is paying attention. You don't know who's going to see your work and say, hey, come and write an article with us. And you don't know, like you could be approached by media also to talk about your research. And I've seen many people who have had one interview that led to many other interviews, and people being interested in just the scientific endeavor, not only about your research. And other people also create things like a nice exhibit about their research, because that's not media is not the only way in which you can engage. You could have an interesting interactive exhibit about your research that could also lead to your story being of interest to media, because now you are reaching a different audience, and now they want to understand where it came from, how you ended up doing what you are doing. And another one is a short recorded video of, of your work, 3-minute video, and you say, okay, fine, I want my research to be out there, because not only does your science being put out there also create visibility for you, it also creates visibility for your institution. It also creates visibility for your growth and development within that field. So you could have a short video, and that short video covers all the important points about your research. Why is it that you're doing that? Why is it that you have done what you've done? Why is it important, and how you have done it, and what is interesting about your research. And another thing that is very interesting, especially for learners and the public, is that visual aids are easier to understand, because you can see where everything started and how it has led to the discovery. And now you understand, and you are able then to engage with the person and ask questions because you have the context. So infographics are perfect, or posters or brochures. These things are very useful when you are trying to engage with the different audiences. And of course, in all of these things, if you're doing it for learners, you also have to understand, okay, these are learners, and this is where they are in terms of their understanding of science. So you make it such that it is something that is relevant to them, not something that is relevant to the other audience, which is the general public, or people like me who are just working within the scientific environments. And so let's say now you have the audience, you have the media. And with that media, there are a lot of people who are listening. So how do you then get to a point where you talk about your research? Because I think a lot of people tend to think, okay, once the press release is written and it's out there and it's been sent and the media person within my facility has said, it's out there, then I can relax. But now you also have to think about your interview. What is it that you want to say? How are you going to say it? And when you are saying it, what is important and what is not important, which then means that you have to prepare for your interview. You can't just assume that, because it is out there, then I'm just going to wing it. You can't wing it because you have to anticipate the questions that are going to come out of it. And in particular, because a lot of people think they're going to be misquoted. So how do you make sure that you guard against things like that? Oh, I'm being misquoted, or my science is is also made too easy to understand. But should it not be too easy to understand, especially when you are talking to a different audience compared to your researchers? What is it exactly that you're trying to achieve? Are you trying to make sure that you are understood and your research is understood and people understand the importance of research or the importance of your research and your contribution overall within the space of science? And I think somebody asked a question about how do you make people care about science? And I think this is the essence of it. How is it that this science is important? What is it exactly that you want us to know about your research, so that when we, like if it's kids, when they come of age and they have to pay tax so that science can continue to be done in the country, they understand the importance of scientific endeavor. And so you have to make it, relatable. And also in the way that you are thinking about it, when you talk about what made you curious, you also want to inspire critical thinking, that, like, this is how everything started, and this is how it progressed, and this is the big picture. And when I was at the lesser picture, then this is how I was thinking about it. But now with time, or over time, this is how I have changed my mind and I'm thinking about certain things. So with that in mind, then you also understand that you have a bigger responsibility when you are talking to media. And also you have to clarify the nature of science, because I think a lot of people tend to understand the importance of it, but they don't understand the journey. A simple example is when we during COVID time, a lot of people had big questions around why is it that we managed to get a vaccine when we have been battling HIV for such a long time, and we don't have the vaccine that is going to help us to fight off all of these things. And so I think a lot of people tended to think that people wanted to reject science, but people wanted to understand the journey to get to that point. And why is it that it was quicker to get to that point when it's not so quick with HIV? And so when you have the platform to think about it, you also shouldn't be dismissive or center yourself in the conversation. You also have to understand that while I was doing this research, I was doing it, and I was doing it with a group of people who understand what it is that we wanted to achieve. But now I'm bringing in a different group of people who are not involved in the process, in the proposal writing, in the data collection, in the analysis, in the writing up. So how do I make sure that those people also understand and they arrive at least at a point where they have the understanding? They might not have the depth of knowledge that you have, but they also want to understand it in the way that is accessible to them. And of course, naturally, the whole point is to share the beauty of scientific pursuit, and to recruit, of course, the people to be part of the bigger picture and the solutions that science brings to society, so that we can continue to invest in science. And on that note, thank you, Dudu.
Thank you so much, Thembela. I see as you were speaking, more questions were coming in. Kamishwa, would you like to ask them yourself, or I can read your questions for you? I can't even see where. I'm struggling to see Kamishwa, so maybe I will. Okay, I'll just read her questions then. If you want to step in, Kamishwa, you can. So the question, I think you had already answered the first question. Then the other ones are how to clarify the nature of science. It goes on to say it's not about research pursuing, it's about communication to people. How to clarify them.
I think the simplest way to clarify research is firstly to think about your audience, because when you think about your audience, then you understand exactly why you are in that space. Because without understanding the audience, and I think this is perhaps the biggest issue with a lot of storytelling, that sometimes we tell a story, but we don't understand why we're telling the story to this group of people. And so the ways in which we think about things are completely different. So if you are in a space where there is the general public, you will know that the story that you have to tell is completely different to the story that you're going to tell otherwise. Say, for instance, you have the general public as your audience. You have to think about what is it that the general public might be interested in your science. And once you understand what it is that they are interested in, because people want to understand why is it so important that we do this particular research. In particular, let's take astronomy. A lot of people want to understand why do we invest in blue sky research. And you contextualizing why you have to invest in that kind of research, the kind of knowledge and the technology that comes with astronomy research, and the understanding of the use of that technology outside of astronomy, then people understand. And the simplest of examples is, like we have nice cameras on our phones now, and we wouldn't have those nice cameras on our phones if it wasn't for astronomy. There are many other things, X-rays and all of these things. So once you understand that, then at least you have a window of which you can also explain why your research then is important and how you position that research. Was it Keshwa who asked the question? Does that answer your question?
Yeah, it was Kamishwa. They can let us know if you, yeah, they're saying thank you. Okay, the next hand I see is from Ferguson. You may speak, Ferguson.
Yeah.
Ferguson, I did not hear the question.
Scientific work they don't even understand. So most often people want very, very
There's something wrong with your sound,
now.
Ferguson. Yeah,
Yes, can you get?
yeah, please ask your question again.
Maybe type it.
Yes, so I'm saying that the knowledge, yeah, the average person who doesn't have any knowledge of your scientific field doesn't want to be bamboozled with so much length of videos or so much item. And I think social media or any of those media platforms, like to catch their attention, is if what you are doing is summarized in a way that is relatable. So, for example, the use of memes. within the scientific field.
Ferguson, we really couldn't hear that. I'm not
That
sure if
forms
you.
of routes. If you could explain further, aside memes, what other that could be used to catch each other? I don't know. Is my question clear?
There are parts of the question that I did not get, so it's very difficult for me to answer. Perhaps you can type something.
Okay, so my question is simple. Like the average person wants the information through memes or very short videos, like stuff that can hold their attention. You know, the attention span of people are becoming very finite, and if they find something too long and boring, they don't stick to it. So what are some of the methods that could be used aside memes and short videos?
Okay, so it's very difficult to answer the question because you are already inferring things that people have shorter attention span. But I think I want to start there. The shorter attention span is that we want to know the thing summarized in short. And from that short summary, then we can go to something that is longer. So if you are able, because there's also there's also something that you have to understand, that as much as you are doing your science, you might not necessarily be able to communicate with all the different audiences. So it's always dependent on how you are presenting the story. So let's start with the 5-minute or the 3-minute video. You do the 3-minute video, and other ways in which you can do this is to write something. And like I said, you can have an infographic, you can have a poster that explains your work. But generally, I think the most important thing is to understand why it is important, because once you hook a person on why something is important, then you make them care, because you want them to understand why it is important to you and why it should be important to them. And from there on, then you move, because even if you have a longer article, if you are not explaining the story such that I care, then I'm not going to be interested. Even in the short video, if you're not explaining it such that I care, then it's not going to appeal to me as well as a member of the general public.
Thank you, Thembela. I hope you answered, Ferguson. There is another question here. I'll read it from Rohan Roy. How to communicate research fields like cosmology and astrophysics to general people? I think you can answer that with experience, Thembela.
I think a lot of people are interested in astronomy, but it's the ways in which perhaps things are communicated. So and this is written down, right? Because I want to answer it in like succinctly. So yeah. So what is key, I find in South Africa, is with the astronomy infrastructure that we have in the country, lots of people are interested to know what kind of research is being done, who is doing that research. And I think maybe we're going to get to a point where we're asking the question, why? And the two that are very, like these two that seem to be very important, I think it's related to the investment. We want to understand if our investment is impactful. If it is impactful, what is the kind of work that is being done? Can we continue to invest in it? So these are very important things. And I think the reason it is very important is because we have a lot of policies and progressive policies that say we don't only have to invest in research that solves the problem of feeding ourselves. We are also an ambitious country that is looking at the scientific contribution a country can have. And in a way, this is South Africa trying to position itself as a big player in research, all kinds of research, including, or in particular, with astronomy, because we don't have the direct benefits. And so the convincing of the general public is mainly on the understanding that these things are not sitting there and not being used. And if they're being used, is it going to continuously be the case? Which is why there is also a huge investment in the next cohort of researchers who will also use this infrastructure. So, and then, you know, of course, people are interested in the kind of people who are being trained, what are they doing, how are they doing that. It depends also on like at the different levels. So there is the scientific research, there's engineering, there are all the other levels, and also the impact the observatories have within the communities where they are located. So it seems to be that's the interest. And I think another aspect that is key is the fact that some observatories, especially the optical observatories, have allowed people to kind of come closer to the telescopes during the day and see what happens and get to understand the work that happens behind the scenes.
Thank you, Thembela, for that. And just to add, with the coming sessions that we will have in this series of science communication training, we will, on the coming sessions, have more focused discussions like communicating a specific science to maybe school learners, or communicating to policymakers, hands-on activities and things like that. There's various topics that are still to be covered. I think we've listed them on the website, but we'll definitely circulate that information again as it comes up and as we prepare for the next sessions. So thank you. There's a hand from Songwe Teddy. You can unmute and speak, Songwe Teddy.
I want to ask a question in reference to media communication. How can you ensure that media communication does not conflict with the government laws and other requirements? Then the second question is, how can you, what are the ethical issues in science communication? Then the other one is that, how can you convince say government, let's say on nuclear implementation, structures and other things, how can you convince the government to buy into the idea of implementing that, even with their negative or other form of opposition?
So I think I can answer the question about what are the boundaries in which scientists can use the media. I don't think there are boundaries really, because unless of course, you know, and of course this is different, unless of course there are rules within your institutes around what can and cannot be said with research. In which case, if you are going to talk to media, then the natural way of doing things is to talk to your public relations or your communications department, because you know there are things that will be contained within the communication policy that says, okay, only this person can say this, only that person can say whatever, whenever, and you know, around communication. However, if it is something that relates to your research specifically, and you have already approached your media person and they've said, okay, with writing a press release or with you saying, I want to talk to media about my science, or I want to put my science in the public domain, then I don't think you have any constraints regarding that, because this is your research. And if you are allowed to talk about your research even at conferences, I doubt very much that there would be constraints about you talking about your research elsewhere within the public domain. And around around the ethics, I guess APJ has already covered this part regarding the ways in which you communicate or you do science communication. But I'll leave that to him to answer. And I'm not sure I understand the way to convince government, because I'm not sure which country you're from. And of course, I might answer this from the perspective of South Africa. So in South Africa, we have a science engagement strategy that has 4 pillars. The first pillar is that we have to promote careers in science, engineering, and technology. And then the second one is that we have to make sure that science is in the public domain so that for societal benefit. And the third one is that we have to also talk about science in order for the people locally and internationally to know the kind of science that that the country is doing. And the ways in which we do that is with science engagement. Science engagement and science communication. I can't remember the fourth one, but given all of this and it being a policy, it does not seem like there are constraints or there are limitations because the policy is written by government. So I'm not sure which country you are from. And I think where then we have an issue or maybe challenges, not really an issue, challenges is that a lot of scientists feel uncomfortable to talk about their science with media, which is why we are having the session, I think.
Thanks, Thembela. I hope you answered Teddy. So I don't know. I think there's a question you referred to APJ or
yeah, there is. So there's a question about ethics. So the person says, "What are the ethics in science communication?"
Well, there are restraints and constraints on the researcher going to the media. A researcher will go to the media when her paper is accepted for publication. But the maturity level of the research, whether it is research and development, research and demonstrated, research which is deployable, there are different levels of research. But great expectations could be raised by the researcher by publishing his or her finding. And there will be great expectations in the people that the outcome of this result will appear in next 1 or 2 years. But there have been researches which are not acceptable for industrial production. I may do in a test tube and I may claim kilograms and tons can be created. So researchers have to be very, very careful that their findings at the laboratory level has very severe constraints. Industrial applications, scaling, large scale ones. That is where the people will look. Will I get this product when? I may do a membrane separation, but from that I may not be able to produce a pharma which is required. So researchers may unnecessarily raise expectations in the public, and it may be necessary for the government to counter that. Therefore, there is a filtering process in all government departments that research findings should be communicated to the media only by appointed scientists. There are levels. But basically, at a very fundamental intrinsic level, the researcher has to be extremely careful that he or she does not raise expectations in the public without realizing the industrial scalability of their finding. This is very important. Remember that thousands of research findings remain unutilized in the industrial sector. Therefore, you have a very high responsibility in this.
Okay. Thank you so much for responding to that, APJ. Thank you, Thembela, for for your presentation. I was about to close and then I see one last hand. So that will be the very, very last hand. And then I'm close. There are 2 hands now. We'll take the last 2, Gordon and Direbe, I think. And then that's it. And then I'd like to close. We are over time now. So you can go first, Gordon, and then Direbe would follow. I don't see Gordon now. Direbe, you... Oh, okay. Let me unmute you.
I can't unmute you.
Am I
You should be.
audible?
Yes.
Yes, yes. No. Thanks for the great delivery. Mine is just a comment, to both colleagues. I believe that such sessions are very much important, especially because, especially on the side of researchers. For someone who deals with researchers, most of the time, it's something that I've realized that they find it very much difficult, to really talk about their research, especially when it comes to technical jargon, because you might find, because I deal with learners, most of the time, so you might find that every time that they need to relate their research, they find it very difficult, to use simple terms. And, you might find that at times the learners end up losing interest in that, in that during that conversation. So such trainings are very much important, to us as communicators and to the researchers as well, because like you said, Thembela, that you need to make this, you need to make your talk, as relatable as possible, because if you're going to talk about something that the learners don't relate to, or can't really understand, it's going to be very much difficult for them or to them, to really grasp what you're trying to talk about. So I think maybe maybe in the country, in South Africa per se, we can have or even in the organizations per se, we can have say that media even though they do have media training. Well, I will talk about the organization that I currently serve. Even though we do have media training, but it must be as broad, in a sense that technical jargons will be able to be simplified, for an example, because let's say we go to outreaches or we go to stakeholder engagements, and when we get there, say for an example, the researcher, is trying to, interpret their research, and they use technical jargons. It's very much difficult for you as a communicator to interpret that, because I think that research is, it's easily explained by the person who's, who did the research, So as a communicator, it's going to be very much difficult for you to really explain that, because you're not the one who's, who was involved in that. So your job is actually to communicate what is being said to you, So I don't know if I make sense. Thanks, Dudu.
Thank you. Thank you so
Thank
much,
you.
Gordon.
Thank you. Thank you for the observations. Yes.
Yes. Now, Duraba, you can speak.
Thank you very much for this opportunity. Is it audible now?
Yes, we can hear you.
You can get.
Yeah. It's a very interesting presentation. This is a rather a different, unique approach in the space science and astronomy, because most of the time, space science and astronomy has to do work with some sort of only research and only scientific community. But this approach is, addressing even the community, the people, because science and technology and research without addressing or incorporating the people, the public, has nothing to do with research. So this is a very interesting tip for scientists and researchers to address the community apart from just engaging in their mere science researches. So that's really interesting. Maybe my suggestion is actually I'm from Ethiopia, and this is an online platform actually. As a startup, this is really appreciable. But what do you think of organizing this kind of engagement in scientific communication programs in different workshops in person in different countries, in person, not only online but in person? Because when it is in person, it will be more meaningful and more engaging, and also it will give a chance for a lot of researchers and junior researchers to join this scientific community. And it also facilitates, like, it may have also other extra scientific activities like cultural and other engagements. So my suggestion is this one, to hold this kind of engagements in person, like used to be before, as of us used to hold some other workshops in Ethiopia. So the same to that, maybe being the first one. There are a lot of energetic young researchers and passionate individuals research interested in space science and astronomy. So maybe if you just support these young individuals from different platforms, that will be appreciable. Maybe my last question is it possible to pursue a certificate for this conference?
Okay. Thank you, Jerebe, for your various points. I think you touched on in-person meetings, and yes, it's something we are looking to do in the future. We will definitely communicate more details, but yeah, we will be having a series of online ones, but we are planning to also host in-person sessions in the coming future. We'll definitely communicate that. Currently, I
Yeah.
think the information was posted on the BRICS Astronomy website, but we're going to launch a standalone website for the community in general so that we can access more information on that platform. And then the discussions today will also be made available online. So people who were not able to attend, or if you like to go through it again, you can access them. And we will definitely ask our speakers to share their slides and make those available as well. And there's been a question or lots of questions about certificates. And yes, we will issue a certificate of attendance or participation to those who are interested. I think you all have received the calendar invite, so you can just reply to that email or to me and request for the certificate, and then we can send the certificates to those who request. Thank you so
Thank
much. I think I've covered almost all the questions I heard. Yeah, and yeah, I think that's it. That's about it. I think that's an old hand, right, Rebbe? It's you're covered now.
Yeah, yeah, yeah. Finished, yes.
Okay, all right. Okay, we will definitely communicate again when we have the next session and the topics to be covered. The website will provide more information. Thembela, I think there was a call to action that you had. Go.
Yes.
Please announce that, and I will follow it up with an email again so that everyone can get the details. So please say that, and then I'll close.
Okay, so the last bit of the session is that we encourage you to record a 3-minute video covering the aspects of your research, and the ways in which you're going to cover your research is you have to think of who, what, and who is you. Of course, you've done this, or your institution or whatever. So who, what, where, when, why is it important, and also how. So you tell that story of your research in 3 minutes in a recorded video, and you send it to Duduzile. The last date for submission is next week, Thursday. And from all of those videos, we might choose one and then send it to a podcaster, maybe Root of Science, and say, talk to this person, and they have they have interesting research. So you have to send that 3-minute video next week. And yeah, that's it. That's it to do it. It's next week.
Yes.
Send it to you.
Yeah.
And I think Duduzile also is going to upload those videos on the website, on the BRICS website, so that anyone and everyone can have access to your short videos, because we do want to know about your research. And those of you who are not doing research, who are science engagement people, you can tell us about the ways in which you communicate science with your different audiences. So you can pick an audience. If you want to explain something that your organization does to learners, you can do that, or you choose the public. But you also have to specify that the group I'm targeting is learners, the group I'm targeting is the public, so that when we look at them, we understand. Did I cover everything?
Yes, yes. I'd like to also say we will definitely also like to share these videos on our platforms, social platforms, to also communicate the science that you are practicing and, get it out there to more people. So please do participate. I think actually we should send out the certificates after that. I'm joking.
Yes.
All right. But yeah, we will definitely keep in touch. If you have any more questions or comments, please send an email and we will definitely reply. We'll be in touch about the next sessions, and I will send what Thembela just announced. I will also send an email to explain the details and clarify the deadlines. Thank you so much, everyone, for attending. We appreciate your presence, your participation. Thank you to the two speakers, APJ and Thembela. Really
Thank
appreciate
you, Dudu.
it.
Thank you, Thembela, for the
Yes.
great, absolutely great. Thank you. Thank you so much.
All right, thank you. Ferguson, the videos will be sent to duduzile@sao.ac.za, but I will send an email after this to everyone, and then you'll get the details. But yeah, thank you so much. Enjoy the rest of your day or good evening if you are in a different time zone. Bye-bye.